Hello, this is Mr. Collier, and today we're factorizing trinomials, okay? They're called trinomials because we have three terms. So we're basically factorizing quadratics that have three terms. Um, so an x squared term, next term, and a constant at the end. First, we'll look at some easier versions, which have just a not equal to, actually this is a equals 1, sorry. Some simple versions where a equals 1, then we'll look at a not equal to 1 afterwards. So a equals 1 is just when there's no coefficient here in front of x squared, or basically x squared coefficient is just 1. So to factorize these, we look for two numbers that multiply to give you 10 and add to give you the coefficient of x, which is negative 3. So those two numbers are going to be negative 5 and negative 2. Okay, so they multiply give you 10. So then we have x minus 5, x minus 2 is equivalent to this expression right here. Okay, so that makes sense because negative 5 times negative 2 is 10. That's why we had to look for two numbers that multiply give you 10. And when you multiply it out, you get a negative 2x and a negative 5x. That combines to give you negative 7x. Okay, next we have a plus 4a, whoops, let's just get into the method there. Just went straight to the answer. We need two numbers that multiply give you negative 12, and now the number in front of a, the coefficient of a, is just 1. So we need two numbers that add to give you 1, multiply give you negative 12. If they multiply give you negative 12, it has to be a positive and a negative. So the two numbers are going to be 4 and negative 3. They multiply give you negative 12, add to give you 1. So it's going to be a plus 4, a minus 3. Okay, if you expand the brackets, you do get this original expression, so they are equivalent. Okay, now we're going to look at basically a not equal to 1. So here we have a 5. And in this step, in this case, we do the same procedure, except we need two numbers that multiply to give you negative 15. So you multiply these two terms. Okay, although I should say that sometimes you need to look for a common factor first and factorize it out, but we'll get to that kind of stuff in a second. Okay, and we need two numbers that add to give you 14 and multiply to give you negative 15. Okay, so that's going to be 15 and negative 1. So this time we're going to take the middle term, which is 14x, and we're going to split it into 15x and a negative 1x. Okay, that's our two numbers right here. And then we can factorize by grouping. So we have 5x times x plus 3. And here there's no GCF, but we always factor the negative. We get the same thing in the brackets here. That means this factorizes to 5x minus 1, x plus 3. Okay. All right, so next, this one here, so just be careful because there's a GCF first. So if you can factor the GCF, it'll actually make it a lot easier. Okay, so it's very important to factor out the GCF. Okay, so then we have this, and we need to find two numbers that multiply, give you 12, 2 times 6, and add to give you 13. And that is obviously going to be 12 times 1. Okay, so we split the middle term. Don't forget the 2 is still there. We have 2x squared plus 12x plus 1x plus 6. Then we factorize out the GCF from the first two terms. And then here, we don't really factorize, but you can write it as 1 times x plus 6. So that factorizes to 2x plus 1, x plus 6. Okay, in our last example, we have two variables. But if you have, let's say, for example, you had just p plus q times p plus q, then you would multiply this out, you get a quadratic like this. Okay, so this is similar, except it's not, there's going to be coefficients in front of the p and the q. So we do the same method. We look for two numbers that multiply to give you negative 24, add to give you 5, those two numbers are going to be 8 and -3, right? So we'll split the middle term again. 2 plus 8pq minus 3pq minus 12q squared. So that's 2p times p plus 4q minus 3q p plus 4q. Okay, so we factorize, we get the same thing in the brackets, so it looks like we're on the right track. This is 2p minus 3q times p plus 4q is our final factorized answer.